right. Yeah, hi everyone. So yeah, my name is Max, but I also go by the name Wizard. And I got this name because I really like to dive deep into internals of modern web technologies. And what I do then, I give away their secrets. So I basically really like to figure out how it all works under the hood and then try to explain that all to you in an approachable manner. So I spent a lot of time reverse engineering. I actually call myself a reverse engineering addict because I spend so much time on that. And there's one topic that fascinates me the most, which is change detection. And it's important to understand this mechanism because change detection is everywhere today. So it's an integral part of most popular web frameworks, Angular, React, and others. Most stateful jQuery plugins and sufficiently advanced widgets like data grids have change detection. And also, there's a good chance that change detection lurks somewhere in your application code base. So in my view, change detection is the most important part of modern web applications because it's responsible for the visible part. Works with DOM, it renders stuff on the screen. So I believe that every aspiring software architect should know this mechanism. That's why I want to take an in-depth look today at it. And we'll start by building a really simple change detection mechanism so we understand the main pieces of it. And then we'll take an in-depth look and understand how change detection works under the hood in Angular and React. So we'll do some comparison. All right? Before I do that, just a few words about myself. So I'm the guy who likes to live on the edge. I already told you that I have an addiction, right? But besides that, can you guys guess what I also like to do from the picture? Yeah, I love trains, but I also like to walk by foot on railroad tracks. I think I've traveled hundreds of miles this way, and I've never looked back. Or maybe one or two times when I heard a horn of an approaching train. Yeah, somewhere in the middle of this, I managed to become a Google developer expert in web technologies and Angular. And just yesterday, I was awarded the MVP. And I was so blown away by how good AgiGrid was and the team behind it that I decided to join the team as a developer advocate. Do we have risk takers in the audience today? Yep. Well, I guess in some sense, we're all risk takers, right? Because we take our chances every day with JavaScript, which is dangerous. All right. So, and also, I spent a lot of time working on Angular in depth. This is the place where I try to inspire developers to grow and reach the level where they can make a difference in this world. If you're an Angular fan looking for some in-depth Angular materials or inspiration, you're more than welcome to give us a visit. All right, so we're back to change detection now. How do we define it? What is change detection? Well, here's my definition. Change detection is a mechanism designed to track changes in an application state and render that state on the screen. Let's say just two pieces on it. And it basically keeps the UI in sync with the internal state of the program. So let's take a look at what rendering means. Well, in any application, right, we take the process of rendering takes an internal state of the program and projects it into something we can see on the screen. So in web development, we take JavaScript's data structures, right, objects, arrays, and the data that they hold, and then we end up with DOM representation of that data, right, images, buttons, and other visual elements. And the process of rendering is, it may not be simple to implement it, but it's still pretty straightforward. And where things become a lot more involved is that when we mix in data, that changes over time. Right? Modern web applications are interactive. Right? Application state can change any time as a result of a user event. Right? Someone clicks on a button, we update some JavaScript object, and then we need to change the DOM. We need to reflect some, for example, image must be removed from the screen, right? And this is change detection. We're detecting the change in the application state and then we re-render. Okay? Well, it might be a little bit more abstract. Let's see some concrete examples. So suppose we need to implement a rating widget. Really simple widget. The number of solid stars on the screen reflects the current rating. It's an interactive widget, so user clicks on any star, it can set a new rating. And we're going to need to store our current rating somewhere, right? So we define an object with the rating property, and the value of the property basically just reflects the current rating. As the user clicks on a new star, we change the rating property, and we need to add or remove some solid stars on the screen. We need to reflect that change. So if we want to implement that using code, right? How do we do that? Well, here's the DOM that we need to create to implement that functionality. Well, basically, it will be just one unordered list with list items. And to render a solid star or a star outline, I'll use CSS classes. So whenever we need to update the new state, whenever the state changes and we need to re-render, what we will do, we'll just simply swap these CSS classes, right? We'll remove solid and add outline, or vice versa. Okay, so that's the idea. Now, let's take a look at the code. So here's the part where we initialize all that stuff, right? Here, again, it's mostly working with the DOM. We're creating unordered list, creating list items, then adding CSS classes, and just append it to the DOM so that it is rendered on the screen. And since the widget is interactive, we also registered an event listener to react on a click. Okay, so this is initialization or initial rendering. Nothing complicated here. Then we know that we need to track changes, right? We need to know when our rating property changed. So to do that, to implement that functionality, we'll introduce setter provided by the JavaScript language. So we define a setter for the rating property. And whenever this property changes, what we'll do, we'll get notified, and then we will re-render. We'll call the update ratings property, which again, as we identified, will simply replace CSS classes. And that's it, right? Now, I want you guys to appreciate how much code we needed to write to implement this very simple functionality. Right? It's a really simple widget. Imagine a lot more elaborate example. For example, a widget that operates on multiple lists, or conditional logic, right? That depends on the state, when we need to hide or show some elements depending on our current state. So the amount of code will grow dramatically, and the complexity will grow as well. And usually we don't want that, right? What we want is to focus on the application functionality, the business functionality, and then let someone else deal with these tracking changes and re-rendering, right? Because here we also need to know how to work with DOM, how to work with the underlying platform, right? It may not be the case for someone who just started in web development. They don't have this knowledge. So how do we solve that? We use frameworks, right? That's what we do. That's why we use them, because they take care for us of the synchronization between the state and the user interface, between our rating property and this unordered list. Right? So if we wanted to use Angular and React, for example, how would we do that? Well, from user perspective, the main, we need to work with templates, right? From the user perspective, this is the main part of configuring a component. And what's interesting is that the way we configure templates is quite similar in Angular and React. Here you can see on the screen Angular and React's templates for our widget. Right? The syntax is a little bit different. However, the main idea here is the same. The idea is that we create an association between a component's property, in our case it's rating, and the DOM element property, which is class name, which is basically renders CSS classes. So here we're saying, okay, when the rating changes, reevaluate that expression. And as a result of this expression, we're going to have either outline or solid string, and then take the string, whatever it is, and use it as a CSS class. Okay? One interesting thing about working with frameworks in change detection. Here you can also see that we are binding to the event listener, the click event. Since our widget is interactive, right, we need to work with that. But what's interesting is that event listeners are not part of change detection, neither in Angular nor in React. They are used to trigger change detection. However, they are not processed as part of change detection. So the change detection process is concerned with components properties, DOM and DOM element properties. Okay, so that's awesome. That's how easy it is to implement our widget. So we use frameworks to do that. But I think that although it is awesome, it also creates some problems. There are downsides. And the main downside to it is that there's no longer incentive for us to know how to work with underlying platform, right? Because everything is abstraction here. Everything is framework related here. And so I want to explain today how change detection works in Angular and React. But before we do that, let me answer the question that I always get asked, which is, okay, Max, why do I need to know that, right? I already know how to configure template in React or Angular. And if you think about it, it's interesting that this question often gets asked, like students, math students, ask their teachers every single year the same question. They ask them, why do we need to know these formulas? Why do we need to know these equations? When are we going to use them? And there are a lot of answers to that question. But the one that I liked the most was given by Darren Sherman. You know what he answered when his students asked him, when are we going to use equations? He said, never. You will never in your life use these equations. And the reason behind that answer, and he went on to explain that math is mental skill. It's a mental exercise. So by studying math, we develop our problem-solving skills, logical thinking. And that helps us be really good at other jobs that we do. And I think that maps really good to programming. When you're trying to figure out how something works, to understand internals of a program, you develop your problem-solving skills. And in fact, this is the #1 required skills by employers. There was a survey, I didn't have it here, but this is what Google does when, or Facebook, when you go on an interview and they give you algorithm, try to figure out whether you can solve a task or not. So by trying to understand how everything works under the hood and digging into it, you develop these skills. Now, the second reason is that I believe that having the fundamental knowledge is necessary to be able to innovate. We don't need just another framework. We need a framework that solves existing problems in a better way, right? It may be faster, or it can be a framework that not only solves these problems, but also teaches us how to solve them. And it's not possible really to be able to come up with that kind of framework or library if you do not know how the existing solutions work, right? You don't know what problems they solve. And if you try to come up with a new solution without understanding existing solutions, you'll just reinvent the wheel. Okay? And if I haven't convinced you that you need to know that, then having an in-depth knowledge about how a framework of your choice works under the hood, having this in-depth knowledge, believe me, will give you an edge during your next job interview. Okay? So let's take a look at how change detection works in Angular and React. And we'll start with Angular. So I showed you that we define a template, right? What happens after that? Well, both in Angular and React, templates get compiled. And in Angular, template is compiled into something called instructions. So this is the output of the compiler. It's a new Angular's compiler called IV. And so these instructions, what do they do? Well, they create DOM nodes and set up bindings. I'm talking about Angular now. And binding as a concept is very important in Angular. Let me expand on what it means. I want to put emphasis on it because it's a very different mechanism to React. React works completely differently. Okay, so here we have a few instructions I highlighted. So the first instruction, element styling, it just creates a binding. It's an abstraction, may not be a direct object, but the binding holds two values. It first holds the value of the current evaluation of the expression. So in our case, for example, we start with the outline string, right? This is the first result of the evaluated expression. And it marks binding as dirty or not. So we start with the dirty false. As we change our rating, the expression gets reevaluated. So Angular processes these instructions again. It does it on every change detection cycle. And what happens is that if we get a new value, for example, solid, right? It just updates the value in this binding and marks it as dirty because the value changed. This is where the term dirty checking comes from. You may have heard that in relation to Angular. So, and this is the job of the first instruction in the change detection block. So every single time Angular runs change detection, takes the first instruction, reevaluates the expression, and updates the binding. Either marks it dirty or not, and updates the value if necessary. Now the second instruction checks if the binding is dirty, and if so, it just takes the current value. In our case, it will take solid property, and we'll use it to update the DOM. Right? We'll just add the class solid. So in Angular, the essence of change detection is parsing template, creating bindings specific to each DOM element property, and then during each change detection cycle, processing of these bindings using instructions. Okay? Now, I was very curious to know, because I'm an Angular guy, mostly I'm working with Angular, so I was very curious to find out how it works in React. And as it turns out, React is completely different. And to be honest with you, I got so used to bindings in Angular that it took me quite a while to figure out the exact algorithm in React. As you can guess, React doesn't use bindings, right? Instead, it uses something called virtual DOM comparisons. And this is a popular term. I think if you Google it, you'll find millions of results that explain virtual DOM. But I want to dive deep into it now in comparison to Angular. So in React, we also start with a template, right? And this template we place in the render function. So in React, every single component has the render function, right? So we place a template there, but it's not simple HTML, right? It's a JS6. It's just HTML plus JavaScript combined. But it's there only until the JS6 compiler does its job and compiles it into multiple calls of the create element function. All right, so once the compiler is done with its job, there is no longer HTML inside. Right? And this is actually made distinction between the mindset of Angular and React, right? Template-based versus JavaScript-based. So here, what happens is this render function. And inside of it, we have multiple calls to the create element functions. And each call to this function creates something called virtual DOM node. It's nothing fancy. It's a simple JavaScript object. I'm going to show it here. That describes an HTML element. What the type of the element is, what's its properties, and its children. Right? And when you have multiple calls to this create element function, eventually you end up with a virtual DOM tree. Okay? And that's exactly what is returned from the render function. So although we started with the template, JS6 template, eventually in React, the render method will return JavaScript object that describes this HTML. What's important to understand is that This render method in React is called every single time React runs change detection for a component. And it may be something that you guys expected, but to me it was quite a revelation. Because again, because of my background with Angular, I thought that because Angular processes template only once and creates these bindings, I thought, okay, maybe React does something like that. I define this template, it calls render method once, returns this virtual DOM tree, right, and then works with it. But in React, the render method is called every single time. And what's important is that every single time it can return a completely different virtual DOM tree, completely different data structure. So suppose we started with this virtual DOM tree, right, where the class name, the expression with our rating property was evaluated to the outline string. Then the expression changes, React calls render method again. We return different data structure, where the class name is solid now. So what React does, it now has two virtual DOM trees, right? So it compares them, I guess you probably know that, compares them and tries to figure out if there's difference on every level of this virtual DOM. If it detects the difference, it generates the patch to update the DOM. Okay? And that is the crucial difference to Angular. Angular processes template only once, generates bindings, and only works with these bindings. Whereas React always works with the entire component's UI using virtual DOM and performs comparison in this way. All right? Now, I've explained to you how change detection works in Angular and React. However, there's one question that we haven't answered yet. And the question is, when does change detection run, right? When does Angular process bindings that works with the DOM? Or when does React call the render method? And if you think about it, there can be two ways to initiate change detection. Well, the first way is to explicitly tell the framework that something has changed, or there's a possibility that something has changed in the state, right? And change detection, so the framework needs to run change detection. It's a manual way. The second way is to rely on the framework to know that something has changed, or that there's a possibility that something has changed. And so there's a need to run change detection and figure out if there's anything that's changed, and so the DOM needs to be updated. And that's automatic way. And this is also where both frameworks differ. In React, we always initiate change detection manually. We do it by calling the setState function, right? There is no way in React to run change detection automatically. Like every single change detection run starts with the call to the setState function. In Angular, we also have that option. We have a change detector object that we can use its API, it's a service, and initiate change detection manually. However, where Angular is different is that there's also possibility to run change detection automatically. How does Angular do that? Well, pretty simple. So we're binding to events using Angular syntax in the template. So in fact, it's the Angular that binds to these events, right? So it knows that a certain UI event has occurred. And so it can just simply wait until the callback is executed. And as a result, the entire application has had a chance to update. And then run change detection cycle after that. And it's a really clever solution. However, it doesn't work for all asynchronous events, right? It only works for UI events, like click events. But we also have timing events, like set timeout. We also have network events, like XHR. So how does Angular solve that problem? Well, it relies on the library called Zone.js. And that library patches all asynchronous events in a browser. And then again knows when a certain event has occurred, so it can notify Angular that this event has occurred. So there's a possibility that the state changed as a result of the event. So we need to run change detection and figure out what changed and whether we need to update the DOM or not. Okay? All right, so we've covered a lot of ground today. Now, where do you go from here? Well, I encourage you to explore the repository that I created on GitHub. It demonstrates under-the-hood details of the change detection implementation in Angular and React. I plan to include all frameworks, Vue framework, and the others that have been mentioned today here. So use the knowledge that you'll figure out here and go explore the frameworks on your own. Now also, most of the knowledge that I've taught you today, that I've explained, I learned through reverse engineering, right? By digging deep into the internals of the frameworks. And I believe that reverse engineering is the most effective way to learn. Yet it's pretty challenging. And so I've written an article where I summarized my experience of reverse engineering, also outlined a few guidelines that you can use to start that process on your own. Okay, now for more insights, follow me on Twitter. I regularly write about some in-depth stuff. I also have plans to write a follow-up article on this topic. I want to include other frameworks to the bundle and show the comparison across all the frameworks. So expect these tweets quite soon. Okay, and so my talk has come to an end. I really hope that the knowledge that you've learned today has awakened hunger in you to learn more. So I encourage you to go and feed it and reach new heights. Because I want you all guys to be extraordinary developers. So thank you for your attention and good luck.